Welcome students. We want to discuss functions of several variables. Before that, we'll start with the quote by Henry Poincaré. So Poincaré was a French polymath and one of the well-known mathematicians of his time, and his work have deep impact even now. So let's begin with the lecture. So what is a function of two variables? So function of two variables, as the name says, you will have two variables as the input variables. So more precisely, a function of two variables defined on domain D. Now D is in plane. So is a rule F which associates with every pair of point xy in D a unique real number denoted by f of xy. So the idea is you have domain, this is your domain. It is basically part of R2, right? It's in the plane. And if you take any point here, you're associating that to a point in set of real numbers, namely a point. So real number will be denoted by this, a point. So xy gets mapped to point f of xy. Yeah. Similarly, if you take any other point AB, which will get mapped to this. So such a function is called function of two variables. So similarly, we can have function of three variables or function of n variables for that matter. So let's see, function of three variables defined on domain D. Now in this case, your domain is a triplet. X, Y consists of triplet of points. So domain D is a subspace of three-dimensional space. Is a rule that associates for each point X, Y, Z in D a unique real number f of X, Y, Z. So this is what it means by a function of two or three variables. Now consider the following example. So let f of xy be x squared plus y squared minus 16, square root of that. The question is it possible to evaluate f of 2, 1? So let's see, can we evaluate f of 2, 1? So when you take f of 2, 1, we get square root of 2 square plus 1 square minus 16, which is square root of, so 2 square 4 plus 1 5 minus 16 is minus 11, and this is not defined. So of course, this function is not defined for all points in the plane. Then the meaningful question to ask is, what are the points for which it is defined? So note a domain of F, xy. Now we cannot have negative numbers inside the square root. So it's all the points xy coming from plane. So plane can be written as R2. So all xy in R2 such that x squared plus y squared minus 16, the inside part of the square root is greater than or equal to 0. And that is, if you look at this, we can first draw x squared plus y squared equals to minus 16 equals to 0, which is a circle of radius 4. So circle of radius 4. So the radius of this circle center is 0, 0. Radius is 4. This is your, and what you need is all such that x squared plus y squared is greater than or equal to 0. So you see that all the points outside this, all the points outside form the domain. So domain is, yeah. So domain is all xy. So if I want to write it again, this is going to be all xy into R such that x squared plus y squared is greater than or equal to 16. and that is all the points outside the circle. Yeah, and including the boundaries. So boundaries are also included because that's where x squared plus y squared becomes 16. Now let's look at this example. So 6xyz, sorry, g of xyz is given by square root of x upon square root of y plus z. Now find the domain of this function. So what is domain of g? Domain of g is going to be all x, y, z such that, so that this domain of this function lies in 3D space. So it's a function from 3D space to R, part of 3D space to R. So domain in this case is going to be, so since we have square root of x on top, we need x is greater than equal to 0. And also we need, since we have square root of y plus z, we get square root of y plus z is 0. So greater than equal to, so we get what? Inside the square root should be greater than equal to 0. Since you're dividing it, we need y plus z to be greater than 0. So this is what your domain is. Now, can we evaluate g of 16, 50, 50? That is going to be square root of 16 divided by square root of 50 plus 50. That is going to be square root of 16 is 4, square root of 100 is 10. That's 2 over 5. Okay. So now the idea is we want to sketch the graph of the function. So what is the graph of function f of xy? So graph of f of xy defined on D is a set x, y, f of xy, where xy belongs to D. Yeah. So it's basically collection of all points. So if you have a D is your domain here, then we get, if this is your domain D, then it's collection of all these points. What points? Points which are of form x, y, f of xy, where xy belongs to D. So this is how the graph looks like. Now similarly, graph of a 3D, so graph of a three-dimensional function. So if D belongs to R3, then it will be x, y, z, f of x, y, z, where x, y, z belongs to D. Okay. So we will not be drawing 3D. We will not be drawing function from space to real numbers. That is will be in 4 dimensions. That's slightly tedious to imagine, but we'll definitely do 2D. Okay. So let's look at the first one. Draw the function, sketch the function, or sketch the graph of the function for f of xy equals to x plus y plus 1. So this is slightly easy to draw because if you look at this, z equals to, if you let z equals to f of xy, that is x plus y plus 1, this implies x plus y minus z plus 1 equals to 0. So we know this is the equation of a plane. We have an idea of how to draw the plane. So what we'll do is we'll draw this graph using intercepts. So let's draw this graph. So we have x-axis, y-axis, and z-axis. So we need 3 points to identify the planes, 3 non-collinear points. So let's take this. So when y and z is 0, x is 1. So let's say y and z is 0, x is 1. When x and z is 0, so sorry, when y and z is 0, x is negative 1. So when y equals to 0, z equals to 0, this gives us x equals to -1. Similarly, when x is 0, y is 0, we get z equals to 1. And then we have when x is 0, z is 0. This gives us y equals to -1. So let's draw it. So what are the points? So one point is -1, 0, 0. So -1, so -1, 0, 0. So here is -1, 0, 0. Next point is 0, 0, 1. So that will be 0, 0, 1 here. And then the other point is 0, -1, 0. So 0, -1, 0. These are the 3 points. If you join them, this is how the piece of the plane looks like. Okay, so we are viewing it from, so it's on the other side of z-axis, right? So this is how this is the piece of plane we are looking at, and this is the graph of the function. Of course, I've just drawn the bounded part. It is defined for all of R2, so this plane will go in our direction. Okay, let's look at the next problem. So in this case, we have let z equals to f of xy, which is 36 minus 4x square minus 9y square. And then when we square on both sides, we get z square equals to 36 minus 4x square minus 9y square, or we get 4x square plus 9y square plus z square equals to 36. And if you divide throughout by, we get x squared by 36, so x squared by 9 plus y squared by 4 plus z squared by 36 equals to 1. Now later on in 12.6, we will see that this is equation of an ellipsoid. And since z is greater than 0, we have only upper part of the ellipsoid. So how will the graph look like? So let's attempt to draw the graph. So how would we draw it? Take basically y and z 0. So if y and z is 0, you will get that x is plus or minus 3. So this is my x-axis, this is y-axis, and this is z-axis. Now since z is greater than equal to 0, so I don't need to worry about that. So now when when y equals to 0, z equals to 0, this gives us x equals to plus or minus 3. 1, 2, 3. Similarly, we have -1, -2, -3. And then y is, so we get for y, we have 2. And then for this guy, we have 2. And for z, we have 1, 2, 3, 4, 5, 6. So when we draw this, this is how the graph will look like. And then we'll later on demystify when we are doing 12.6 on how to draw graph of these kind of functions. So it is this ellipsoid. Okay, I'm just drawing some contours there so that we can understand what is happening. So this is the shape of this ellipsoid there. Okay. Now comes the idea behind the contours and level curves. Note that these are the curves which help us to be able to sketch the graph of the function. So what is a contour curve? So contour curve of height k is essentially you take the surface z equals to f of xy, and then what you do is you draw z equals to k plane. So for example, if I want to have contour curve of height as it seems, so of certain height, then I'll take a plane and then I'll cut it. I'll get, so this is already drawn here. So this corresponds to k equals to 35. So z equals to k equal to 35. So these curves you get on top are called contour curves. So these curves are contour curves. Now, if you project it down to xy plane, because we would like a planar representation of things in the plane, they are easy to draw. Then those are called level curves for f of x, y equals to k. So essentially you're solving xy such that f of xy equals to k. This is your level curve for f of xy equals to k, right? Now, what is your contour curve? Contour curve is set of all points x, y, z in such that your f of xy is equal to k. This is the contour curve for z equals to k. So the difference between contour curve and the level curve. Again, level curve lies in xy plane, whereas contour curve lies on the surface with that intersection. So these are the few these are a few level curves. So you see that this is your curve, and if you see from different direction, this heights correspond to these guys here. There's one more hidden, which you can find here. And then corresponding to different values of k, for z equals to k, you get these level curves. So level curve actually give you quite an idea about how the 3D object is, right? Because to understand the 3D object completely, let's look at these two 3D objects, for example. You will have to see it from different angles, right? You have to see it from this angle. You see, okay, there are three peaks, but two peaks and one valley, but actually there are these many of them, right? Four of these guys. So it basically, level curves gives you an idea about how the 3D surface looks like. Yeah. Again, some information is lost, of course, right? Because I mean, how can you encode three-dimensional information into two-dimensional information? That is not happening, but still, it gives you sufficiently enough information to do certain kind of calculation. So for another example of level curve is the following. So you see this mountain, and here are the level curves. So basically, if we zoom out, so we are asking when is k equals to 5100. So you're asking when is the height equals to 5100. So this is that. Then when is the height 5000? So it's basically this curve. When is height 4700, 4700? So these are the level curves we get. Okay. So now let's draw. So let's draw a level curve for f of x equals to x squared plus y squared for k equals to 0, 1, 2, 3, 4. So first of all, we take f of xy and equate it to 0. This means x squared plus y squared equals to 0. And that is simply just a, that is essentially just a point, right? So that is going to be just a point. Now, what about when k equals, so this is your k. So when k equals to 1, you get f of xy equals to 1, x square plus y square equals to 1. So that's a circle of radius 1. It's a circle of radius 1. Okay, so I should basically write down here z equals to, for this guy it says I get k equals to 1. Now similarly, if I have f of x, y, z equals to x square plus y square, in this case if k is 2, I get a slightly bigger circle, right? So bigger circle of radius. So I get a circle of radius square root of 2. So square root of 2 is bigger than 1, right? It's 1.41 something. So we get circle of radius bigger than 1. So this corresponds to k equals to square root of 2. Then next one would be 3. So we get f of 3. So we again are solving for x square plus y square equals to 3, which is a bigger circle. So okay, so bigger circle, k equals to, so k equals to 2 here, my bad, not square root of 3. So k is 2. Here we get k equals to 3. And then for k equals to 4, we get a circle of radius. We get a circle of radius what? 2. So this corresponds to k equals to 2. Sorry, k equals to 4, right? So these are the level curves. Now let's look at the following. Sketch the level curve for 9 minus x square minus 4y square for k equals to 0, 1, 2. So again, we have k. If k is the level curve, we get what? We get f of x, y. We need k equals to, k equals to 9 minus x square minus 4y square square root. Now if you square on both sides, we get x square plus 4y square equals to 9 minus k square. All right. So in this case, if we notice that first of all, this has to be greater than or equal to 0 because this is sum of two squares, and and then you multiply by 4. So this is sum of two squares really, right? X square plus 2y the whole square. So it can't be negative. So this means what? 9 minus k square has to be greater than or equal to 0. This implies no level curve for k 9 minus k square less than 0, right? That is k greater than 3. No level curves for k greater than 3 or k less than minus 3. Okay, so there are no level curves in that scenario. So we only have level curves in this setup. So let's see, for k equals to 0, what do we get? So we already have k equals to 0. So for k equals to 0, we have x square plus y square. So k equals to 0. X square plus y square equals to 9. And if you look at this guy, this is same as x by 3 square plus y square by 3 by 2 the whole square equals to 1. Right? That is an ellipse essentially. So how does this ellipse looks like? So x is, in x we have 9, so plus or minus 3. So 1, 2, 3, 1, 2, 3. So we get an ellipse. And what is the value of y? Y is 1.5. So 1 is here, 2 is here, so 1.5 is somewhere here. So it corresponds to an ellipse. k equals to, so we get ellipse for k equals to 0. So this is your level curve for k equals to 0. Now what about k equals to 1? If k is 1, we get x squared plus 4y squared equals to 9 minus, so 8, which will mean that x squared by 2 root 2 the whole square plus y by square root of 2 square equals to 1. Again an ellipse, but with a smaller radius. So we get slightly smaller radius. So 2 root 2 is less than 3. So we get so we get 8, which is 2 root 2 the whole square. So we get a smaller ellipse. Okay. So this corresponds to k equals to 2, sorry, k equals to 1. And similarly, if you take k equals to 2, you will get even smaller for k equals to 2. Okay, so this is how the level curves work. Okay. Now, what are level surfaces? So if we do the same thing in 3 dimensions, so we want to basically have f of x, y, z equals to k, then we get level surfaces. Now note that it's not possible to draw a 4-dimensional object. So the way we understand the graph of a 3D, that means function from D, which is subset of R3 to R, is one viable way would be to understand the level surfaces. So for example, if you take x squared plus y squared plus z squared as a function, then if you take f of x, y, z equals to 0, then you will get x squared plus y squared plus z squared equals to 0, which will be just a point. So the level surface is just a point. If you take x squared plus y squared equals to, say, k equals to 9, this corresponds to what? K equals to 9. So k equals to 9 is a sphere of radius, sorry, it's basically a sphere of radius 3. Similarly, if you take k equals to 4, then it's a sphere of radius 2. If you take k equals to 1, then you get sphere of radius 1. So these are the level surfaces. And if you take k equals to 8, then it will be some sphere in between these two spheres. So this is how you get the level surfaces for. Now let's proceed on finding the level surfaces for f of x, y, z equals to x squared plus y squared minus z. So let's see a few level surfaces for this guy. So first of all, let's take, so this is your k when k is 0. When k is 0, we get x squared plus y squared equals to z squared, sorry, z. And if we draw this, this looks like a surface z equals to x squared plus y squared. So z is always positive. And when we do 2.6, we'll learn on how to draw this correctly. For now, this is how. So let's increase this line length. Okay, into the shape should go. So this is a surface corresponding to z equals to k equals to 0. Yeah. Yeah. Now next one, k equals to 1. So if we do that, we get 1 equals to x square plus y square minus z, or z plus 1 equals to x square plus y square. So now this is same as this curve but shifted down by 1 unit. So same as this curve but shifted down by, so shifted down by 1 unit. Again, some contour to give it a 3D picture. Okay, and so on and so forth. So this gives you the level surface for the function f of x, y, z equals to x squared plus y squared minus z.